Hello students, welcome to the class, and in today's class we are going to discuss gravitation. Do you know why we do not fall from the earth? Do you know why planets revolve around the sun? Do you know why moon is revolving around the earth? All these questions will get answered today in this class. Look, this must have amazed you for years that this is earth, and if we are here standing here, then it's fine. But if we are standing here, then people who live downside of the earth do not fall into the space. Why? Because of the gravitation. Now we know there is a force. If I push you or I pull you by holding your hand, then there is a force applied that is visible. But in nature, there are several forces which are not visible, like magnetic forces, electric forces, and gravitational forces. You must have played with the magnets, right? You bring closer two magnets, there will be two phenomena, attraction and repulsion, right? But similarly, as the magnetic force is invisible to you, similarly gravitational force is also invisible to you, but it applies between any two objects, or each and every object is applying gravitational pull to each other. Why I am saying pull? Because gravitational force is only attractive force, it does not include the repulsion, right? So you must learn first thing, gravitational force is an invisible force. Second, gravitational force is pulling force always, right? Attractive force always. Now here comes why Earth is drawing the apple. You must have heard this story, right? Earth is getting back the apple from the tree, but stones are not getting upside towards the tree because of the difference in masses, right? We can learn from here. Say F equals to, we know third law of Newton, right? Every force has an equal and opposite reactive force, right? Say force on apple by earth is equals to force on earth by apple. Same way, but apple is drawing towards the earth, but apple is not going back, or earth is not going up to the apple branch to which the apple is falling. Why? Because F equals to m into a, mass into acceleration. Here say mass of earth and acceleration of earth equals to mass of apple equals to acceleration of apple. Acceleration means any agent which is completely responsible for the getting the speed of any object, right? A mass of earth is very large, then to make these two quantities equal, we need acceleration to be very less. That's why earth is not getting any acceleration due to the apple, but mass of apple is very less, so acceleration of apple is very high to make these two quantities equal. Okay, now we come to the universal law of gravitation. Okay, let's see what this law states. In the universal law of gravitation, there is first thing that it is not only applicable between heavy masses, it is always applicable between every masses present in the universe, all the masses. The thing is, small masses do not apply a significant force to pull the things towards them, right? Like I am applying a gravitational pull to this board, and this board is also applying a gravitational pull to me. But because the masses are not significant enough to draw me towards the board or the board towards me, but heavier masses are significant agents to apply these type of gravitational pull. That's why we see gravitational pull to be in between planets, in between planet and satellites, and like earth is pulling everything towards the earth in its gravitational field. Now what is the gravitational law? The force applied between two object, the force applied between two object is directly proportional to the product of two masses. Like if there is two masses, like this is earth and this is moon, okay, this is having mass m1, this is having mass m2, then the force between these two planets or these two masses will be directly proportional to the product of these two masses. Force of gravitation will be directly proportional to the two product of these two masses, and force will be inversely proportional to the distance between these two masses, square of the distance between these two masses. So if we merge both of these equations, what we get, F is proportional to m1 m2 upon d square. Okay, if we remove this proportionality constant, then we get F equals to g m1 m2 upon d square. And what is g here? G is the universal gravitational constant. G is the universal gravitational constant. What is the value of G? Value of G, standard value of G is 6.67 into 10 to power minus 11. Okay, what will about the unit? Unit we can get from here. This is the final formula for the universal gravitational force. From here we can get what will be the G? G will be F into D square upon M1 M2. Now, if we talk about the unit of G, F is force, unit of force is Newton, D is distance, unit of distance is meters, so it will be meter square upon mass kg into kg, so it will be kg square. So what will be the unit of this? Newton meter square upon kg square. Okay, so this is the formula. This is the formula for the gravitational force. We can also write it like Fg. Okay. In exams, you will require to prove this formula by using these two equations. You must learn these two main objects or these two principles, that it is only applicable between the heavy masses. It is applicable in every masses, but it is significant in the heavier masses, and it is directly proportional to the multiplication of the two masses, and it is inversely proportional to the distance between the two masses, square of the distance between the two masses. So I think this is all the, you can also see completely if you want to note down. I think this is the gravitational part, and rest we can see in the next lecture, the numericals.